Hey guys, today we're doing 10.4 dividing radicals. Okay, so the first thing that we want to talk about is the fact that we can have a square root over the entire fraction, or we can split it up into a square root on the top and a square root on the bottom. So depending on the values in the problem, sometimes it might be more beneficial to reduce the fraction, okay, and that way it would be written under one square root, and then other times when that's not possible, we're going to want to square root the top and square root the bottom separately. So looking at our first example here, okay, I notice that 4 and 36 can be reduced as a fraction. So I could reduce both of those by 4. My fraction could be 1/9. Now it's not going to reduce any further, but I see that 1 and 9 are both perfect squares. So I could separate and do square root on the top and a square root on the bottom, giving me 1/3 for a final answer. Now in example 2, I have 49/100 all underneath the same square root, but 49 and 100 are not going to reduce. So in this case, it's more beneficial to square root the top and square root the bottom separately, because if I notice now, 49 and 100 are both perfect squares. So I could square root those separately. I could have 7/10 for my final answer. Let's make things a little bit more complicated, okay? And let's put some variables in. Okay, I'm looking at example number 3. They're in separate square roots, but I noticed 27 and 3, I could definitely try and reduce that, and an a cubed and an a cubed, I could definitely do something there. So I'm going to want to put those back together underneath one square root so that I can first simplify the fraction. Okay, 27 divided by 3 is 9, and a cubed over a cubed, well, that's going to cancel out. So I'm really just looking at the square root of 9, which is 3. So it went from looking kind of like a complicated example to just being a very simple square root of 9. Okay, example number 4. So I look at my coefficients, and 16 and 9, I can't reduce those by anything. But a to the 4th over a squared, I could try and subtract my exponents, okay? And I could reduce that a little bit and just get an a squared on the top. Okay, so remember, when we divide variables, we subtract the exponents. Okay, so that's how we get an a squared on the top. Well, now I'm looking at this expression, and 16 and a squared, those are perfect squares, and a 9 is perfect square as well. So it would be most beneficial here if I split them up into two separate square roots. So 4a on the top, 3 on the bottom. Remember, when we take a variable out of a square root, we need an even exponent so that we can divide it by 2. Now, what happens if I can't take the square root on the bottom? What if I don't get a perfect square? So there's one major rule when dealing with radicals, and that's that you cannot leave a square root in the bottom of a fraction. If and when that happens, you get something that you can't simplify out of a square root, we have to do something called rationalize the denominator. And that means getting rid of all of the radicals that are in the bottom. Okay? It's actually a very simple process. So I'm looking at example 5. My fraction of 2/3 is not going to reduce. So what I've been doing up until this point, splitting it up into two square roots. So square root of 2 over square root of 3. Now, we know that 3 is not a perfect square, so I'm going to be left with that radical on the bottom. Okay, if you've noticed, through some of our example problems in previous sections, when you multiply a radical by itself, the radical actually cancels out. Okay, so the square root in the denominator is the one that's causing us a problem here. So what if I try and multiply top and bottom by the square root of 3? So remember, you can multiply to a fraction as long as you balance the top and the bottom with the same value. So the denominator here, this is what's causing me a problem, which is why I'm using square root of 3 to rationalize. So this step right here, this is where I'm rationalizing. Okay. So remember from our 10.3 multiplying radicals, we can multiply inside when they are unlike. So I can do square root of 2 times square root of 3. I get square root of 6. Okay, on the bottom, I'm going to do square root of 3 times itself. I get square root of 9. So I can't simplify the top, which is fine, because the denominator is what I'm most worried about. So the square root of 9 simplifies out to just be a whole number without a radical, which was my goal. Okay, so multiplying a radical by itself, we can see through our work in the denominator here that when we do that, the square root just cancels out and we're left with what's inside. Square root of 3 times square root of 3 equals 3. So square root of 7 times square root of 7 would just equal 7. Let's try another example. So 7 over 5x, we know that that's not going to reduce as a fraction. So we split up our radicals. Okay, well, this square root of 5x in the bottom, can't leave that there. We know that that's not simplifying. So we're going to take whatever's in the denominator and we're going to use that to rationalize. So we're multiplying by the square root of 5x on top and bottom. Okay, across the top I get a 35x. And on the bottom, if I did that multiplication, I would get 25x squared. Now, as you do more of these problems and the better at it that you get, you may not have to write 25x squared. You're going to start to realize, oh, the radical times itself is just what's inside. Can I simplify anything here? 35 and x, nothing will break down, so the top is going to stay. But 25x squared on the bottom, both of those are perfect squares. That equals 5x. Now, remember, I cannot simplify the 5 and the 35 or the x and the x, because in the numerator, one is under the square root, and then in the denominator, the other one is on the outside. So they're not going to cancel with each other when one is inside and one is outside. So this has to be my final answer. Pause the video at this point and try and do examples 7 and 8 on your own. Okay, I'm going to go through and do the work for these. So we're going to use square root of 6. Okay, we get square root of 48. Okay, and I'm going to start to cut out that middle step. I'm just going to have a 6 in the denominator. Okay, now 48, I know that I can simplify that. I can make it a 16 and a 3. So in the numerator here, I have a 4 square root of 3 over 6. Now, if both the 4 and the 6 are on the outside, I could reduce those. So 4 and 6 I can reduce by a 2. So I get 2 root 3 over 3. Now, if you wanted, from the beginning of this example, you could have briefly put the 8 and the 6 back inside the same square root and reduce your fraction first. Okay, dividing both of those by 2. Okay, and then you would have rationalized using square root of 3 on the top and the bottom. Okay, and we would have arrived at the same answer. Okay, so either method is perfectly acceptable. All right, number 8. Use 15. So remember, we're always using the denominator. Okay, and I can simplify 45. I'm sure you've gotten better at recognizing these. Okay, I can do a 9 and a 5. All right, remembering when there's a number on the outside to begin with and a perfect square comes out, they're going to multiply. So I have 6 square root of 5 over 15. The 6 and the 15 I can reduce. What am I reducing by? By 3. So 2 root 5 over 5. Remember, the 5 inside and the 5 outside cannot simplify. This is my final answer. Okay, one more example like this kind. Okay, so I just have one square root on the bottom, so I'm going to use square root of 2 to rationalize. But what's different about the numerator? Well, the numerator now has 2 terms, so we're going to make sure that we distribute on the top. So we get 2 root 2 minus the square root of 28. Okay, and there's just a 2 on the bottom. So now I want to look at what kind of simplifying can I do here? So 28, what could I do with that? We're going to take 28 and we're going to divide by our perfect squares. Do 7 and 4. Okay. So 2 root 2 minus 2 root 7 over 2. Now, the reducing game has changed a little bit. We have to make sure that we use all 3 of these numbers when we try and reduce. So if we think of, kind of like when we did quadratic formula, you had to make sure that you used all 3 numbers on the outside when you wanted to reduce in the end. Same idea here. Okay, so everything outside, all of the terms on the top and the term on the bottom need to have something in common. So 2, 2, and 2 can simplify all of those. 1 root 2 minus 1 root 7 over 1. Now you don't have to write any of those ones, so you could just say root 2 minus root 7. And that would be your final answer. Now, up until this point, all of our denominators have just been one radical. But what happens if now I have a binomial? So I have one term plus or minus another term, and there happens to be square roots. We're still going to rationalize. We just have to use a different value. So the value that we're going to use to rationalize now is something called the conjugate. So the conjugate means we take whatever expression is in the denominator and we change the sign that is in the middle of the 2 terms. So this example, my conjugate would be 3 minus the square root of 7. So it's still going to be just like it was last time. We're going to multiply top and bottom by some value. It's just going to be a binomial this time, and we're going to make sure that we flip the sign in between the 2 terms. Okay, so my first example, we'll start off slow here. So my denominator is 2 plus the square root of 7. which means that my conjugate has to be 2 minus the square root of 7. So I'm going to use that to multiply to my original problem here. So 2 minus the square root of 7 on the top and the bottom. Now, since this is a binomial, I'm going to put it in parentheses to try and decrease errors when I multiply. So we saw before, in a situation like this, we have to make sure that we distribute. Okay, so we're distributing on the top, and take a look at the bottom. What are we going to be doing on the bottom? Binomial times a binomial. That's right, this is FOIL. All right, so let's start with the top. That seems to be the easier part. So 5 times 2 is 10, and 5 times negative square root of 7. Okay. Now, if you need to take your FOIL and write it off to the side so that you can draw your arrows. Okay, might not be a bad idea. So 2 times 2 is 4. 2 times negative square root of 7. Okay. 7 times positive 2. And then positive square root of 7 times negative square root of 7. Multiply those outside. So a positive times a negative is a negative. And square root of 7 times itself is just a 7. So let's put these terms back in here. What do you notice about your FOIL? Look at all 4 of those terms. Do you see that the 2 in the middle have opposite signs and that they're canceling each other out? And when that happens, you no longer have a square root in the denominator, which was the whole goal of rationalizing. So in the denominator now, I just have 4 minus 7. 4 minus 7 is negative 3. There was nothing in the numerator that I could break down, and when I look at my 3 outside numbers, 10, 5, and negative 3, nothing simplifies into all of those. So this is my final answer. Okay, if you need to take a minute and pause the video to really look through the work and see what happened, I suggest doing that right now. Let's take a look at another one. So 2 minus the square root of 6 on the bottom means that my conjugate is going to be 2 plus the square root of 6. So top and bottom here is 2 plus the square root of 6. Well, looking at this, I'm going to have to FOIL in the top and in the bottom because both of those are binomials. Okay, so again, if you want to write your FOILs off to the side of your problem, I highly suggest doing that so that you don't make any mistakes. Okay, so I'm doing square root of 3 times 2 and times radical 6. And then we're doing 10. Right, and now my denominator, 2 times 2 is 4. 2 times the square root of 6. And negative square root of 6 times 2. When I get to negative square root of 6 times positive square root of 6, multiply the outsides first, where we get a negative 1, and then the square root cancels itself out there. Okay, so the first thing I want to do, I see those opposite signs in the bottom. I really want to cancel those out. Okay, so I'm left with 4 minus 6. In the numerator, I'm looking at all my square roots to see, is there anything here that I can simplify? So 2 root 3, nothing will do it. 18, I could do a 9 and a 2 there. 20 is a whole number. 10 root 6. Nothing is going to split that up. Okay, so I'm looking at 2 root 3. Square root of 18 becomes 3 root 2. Plus 20 plus 10 root 6. So do I have any like terms on the top? I have a square root of 3, a square root of 2, and a square root of 6. Remember, when you add and subtract, the radicals have to be the same in order to combine, so I can't do anything with that. Okay, I want to continue to simplify here, so 2 minus 6 on the bottom. I'm going to make that a negative 2. So then the last thing I want to do is see if I can simplify any of these outside numbers. So 2, 3, 20, 10, and the negative 2 on the bottom, no number divides into all of them. So there's no like terms to combine on the top, and there's no coefficients, outside numbers, to reduce here. So this is my final answer. So don't be afraid if you get an answer that has a lot of terms in the top when you're done. Sometimes when you're rationalizing, things are not going to combine, things are not going to simplify, and you are going to be left possibly with more terms than you started with.